Hey guys, welcome back. We're going to go ahead and do our next lesson, which is section 9 or chapter 9, and it's going to be sections 3 and 4. We're going to be talking about box plots today. First thing I want you to do is, if you go on Google Classroom, you can print out a blank version of these notes, and you can fill them in as we go through the video. If you don't have a printer, then I would just recommend you get some blank paper out and you just follow along and write down everything that you see on the screen, okay? First thing on these notes is, just so you know, this problem over here on the left of the first page, this is actually from the previous topic, so we're not doing that on this video. We're going to start over here on the right, and I need you guys to make sure that you are recording your name and your period number on top of these notes. That way I can easily distinguish from them when I'm grading them, because part of your assignment for this is going to be turning in a copy of your notes so I can see that you're participating in class and paying attention to the videos and whatnot. Okay, so box plots. Box plots are a graphic representation of data. It does not give you every individual data point that's in the data set. Box plots are used to show the 5-number summary. A 5-number summary, that's this terminology right here, 5-number summary. A 5-number summary tells you the minimum value that's in the data set and the maximum value that's in the data set. So the bottom of that data set and the tippity top of the data set. It tells you the first quartile, the median, and the third quartile, and what that is you're basically splitting your data up into 4, and you're finding what those points are, where those quarter points stop. So we're going to explain exactly how you do that in just a moment. A box plot typically looks just like this, and then it'll be on a number line, so you can tell what numbers are associated with each part of the box plot. But let's go ahead and label the one that we see here on the paper. The very first line here will correspond with the minimum. The very last line will correspond with the maximum. That's the lowest and highest values in the data set. The midpoint line here, which is inside of this box, that's why we call it a box plot. The midpoint here is going to be the median. And then we have these other 2 pieces of data called the quartiles. This is the first quartile right here. This is Q1, or quartile 1, the first quartile. And then this one is the third quartile, which is Q3, or the third quartile. So what is a quartile? So basically it's a section that contains 25% of the data. And that's basically what's meant when you say quartile, and that's why we call it that. Okay, so let's turn the page. On the next page, we're going to be talking about the differences when you have an even number of data points and when you have an odd number of data points. There's a distinction there in terms of how you're finding Q1, the median, and Q3. If you have an even set of data, you're going to split that data up into 4, okay? You're going to have your first quartile, your second quartile, your third quartile, and your fourth quartile here. This is the 4 quarters of the data. The median will be easy to find because it will be the average of these 2 values, and it cuts the data exactly in half. And then the bottom half, or the lower half of that data here, has also a median. The median here is the first quartile, okay, because that cuts the lower half into half, if that makes sense. And how do you find this value? You average the 2 points that come right up to the Q1 area there. In the top half, you have, let's say in this example, there's 8 data points, so there's 4 in the bottom, 4 in the top. The top half would be split into a quarter by cutting that in half too. There's 2 points and there's 2 points. The Q3 would be found by averaging these 2 values right here. And then you have your min and your max. That's the top and the bottom of the data set. When you have an odd data set, It's a little easier to find the median, the Q1, and the Q3 because you don't have to find any averages of any values. This literally, this value right here will be Q1. This value right here will be Q3, and this value will be the median. The only difference is what is the lower half of the data and what is the top half of the data. The lower half will be from the minimum up to just before the median, and then the upper half will be the just after the median up to the maximum. Okay. So here we have an example. It says consider the following data set that has an even number of values. So if it's even, that means we're going to be using this scheme up here. And what we need to do, well, really what we need to do is we need to put this data in order because it's currently not sorted. So we want to make this in order from least to greatest. So let's go ahead and do that. I'm going to use the bottom of my paper here to do it. And it actually looks like it's just 1, 2, 3, 4, 5, 6, 7, 8. So that's pretty easy. Let's just rewrite that. 1, 2, 3, 4, 5, 6, 7, and 8. And then the minimum and maximum, that should be pretty easy to find because the minimum is always the lowest and the maximum is always the highest. So that's 1 and 8. The next thing they want us to look for is the median. So first thing we need to do, since we have an even set of data, is we need to cut this into half, and then we need to cut the lower half in half, and then the higher half in half, if that makes sense. Okay. The median is going to be found by averaging these two values in the middle. So average these. To get, you can't see what I'm writing, but I'm going to go ahead and scoot it up so you can see it. Zoom out one. Okay, the 4 and 5, right around the middle here, you're going to average these in order to find what the median is. So the median is 4.5. It's 4.5. Okay, the first quartile, if you're just looking at the bottom half of the data, that's 1, 2, 3, and 4. You're going to average 2 and 3, whatever is right around that middle point here. I can't spell. That says average. Average to get Q1, or the first quartile. So 2 plus 3 is 5, divided by 2 is 2.5. So we're going to put 2.5 as the first quartile. And then you guessed it, the third quartile is going to be found by looking at the upper half of the data. And then here's the midpoint right here. So you need to find what this value is by averaging this. Okay. So we're going to average to get Q3. 6 plus 7, and then you divide that in half is 6.5. 6.5. Okay, so what you've just found is you've found the 5-number summary of the data. You found the min, you found the max, you found the median, and you found Q1, and you found Q3. So that's the 5-number summary. You found all of that. All they want you to do in this problem now is just plot this on the number line and actually draw the box plot. So we're going to go ahead and do that. We're going to label this number line first. My data only goes from 1 to 8, so I'm just going to pick any place to start here. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so my min point, we're going to plot something. Here's a dot. My maximum point is 8. We're going to plot a dot there. And then the median is right in the middle. That's 4.5, which is in the middle of 4 and 5. So we're going to do a dot for that. The first quartile is 2.5, so that's between 2 and 3. Here's a dot at 2.5. And then 6.5 is my third quartile, so that's between 6 and 7. And there's a dot. Now, how you turn this into a box plot? Simple. Just connect the first 2 dots, connect the last 2 dots, and then in the middle, make a box. Don't forget to draw the line for the median, and that is our box plot. So you're going to have an assignment that goes with this in Delta Math, and they refer to it as a box and whisker plot. It's the same thing. You've probably used this terminology in the past, but it's the same thing because it's a box, and then it appears as if the box has two whiskers on the outside. So that's why they call it a box and whisker plot. It's an interchangeable term. So let's go ahead and turn the page. And on our next page, it asks us to do some observations about our box plot. So actually what I need to do is I need to put these side by side. So there's our box plot, and okay, great. Actually, I might want to show the data too, so let me do this. Okay, that's probably as much as I can fit on one screen, so we'll just go with that. Okay, the lowest 50% of the data values. So we're going to need to go back over here. Let me move my camera out of the way. If we come down here, we have the values 1, 2, 3, and 4, and that is the lowest half of the data. So that's the bottom 50%. And so the values range from 1 to 4. 1, 2, 4. And then the highest 50% would be the upper half, so cover that. And your values go from 5, 6, 7, and 8. So the range there is from 5 to 8. 5 to 8. The middle 50%, which is the box area, represents the values from blank to blank. Okay, so we're talking about the box now. So go over here to the box and whisker plot, okay, the box plot. The box is the only thing we're talking about right now. We want to know what's the lowest point and what's the highest point. Well, we know this is Q1, and we know that this is Q3. So we already figured out what our Q1 and our Q3 are. So the range here is from 2.5 to 6.5. Okay, so let's read the question very carefully because it looks like it says the middle 50%, which is the box, represents the values from 2.5 to 6.5. So let's go back to the values, which is down here. These are the values in our data set, okay? And we know that the box represents the second half and the third half put together. So what values fall in this range? Well, it's 3, 4, 5, and 6. So really, this would be an incorrect method to find this, okay? The values that fall in this box, you have to go back to your original data set and think about what quartile or what quarter of the data this represents. What data points fall in there? So it's actually 3 to 6. This middle 50% is also known as the IQR. That's the interquartile range. That would be the values that fall between Q1 and Q3 inside of our data. Okay. The first quartile represents the lower 25% of the data, which is also known as the 25th percentile. And then the third quartile represents the first 75% of the data. That's from the minimum all the way up to Q3. So that's the first quarter, second quarter, third quarter, fourth quarter. So that's 75%. That's the 75th percentile. 75% of the values are above what number? So if we look at this again, actually, let's go to the data and do this because we need to know we're talking about the values here. Okay, so go back to our data, and this is 25%, this is 25%, this is 25%, and this is 25%. So the 75% of the values are above what number? Start at the top and go back down. All of these 3 quarters added together make 75%. So 75% of the data is above 2. It's above 2 because it's 3, 4, 5, 6, 7, and 8. Okay. And then 25% of the values are above what number? So let's look at this again. So 25% of the data, start at the top because the keyword here is above. 25% of this data is above 6. The median of the lower half of the data. Okay, so once again, go back here. Look at the lower half. The median of the lower half is Q1, which is the average of 2 and 3. So Q1 is 2.5. And the median of the upper half of the data, so go back to the data, that's 5, 6, 7, 8. The median is the midpoint here. So 6 and 7 averaged together is the median there, and that's going to be 6.5. Okay, so that's enough about that problem. We're going to go ahead and move forward now to the second part of this section, which is box plots part 2. Consider the following data sets. So we have data set 1 and data set 2. I'm going to use 2 different colors to represent this. So this one will be blue, and this one will be the pink data. And this is already sorted, and so is this one, so we're good to go. It says complete the following table. So basically, we're finding the 5-number summary for each of the data sets because that's what they're asking for, the min, max, median, and first and third quartiles. So I'm going to use my blue pen to represent the first data set. The minimum here is the lowest value of 1. The max is the highest value of 23. The median, okay, so this is where it starts to get tricky because you have to start looking at your data. So how much data is in here? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 points, which means we have an even data set, which means we're going to have to do some averaging. So if we were to cut this in half, that would be the halfway point, and half of the half is there, and half of this half is up here. Okay, so the median is going to be the average of 7 and 9, which is 8. The first quartile will be the average of 3 and 5, which is 4. And the third quartile will be the average of 11 and 13, which gives us 12. Okay, let's do the same thing again for data set 2. The minimum is 1. Maximum value is 15. Okay, the median, so 1, 2, 3, 4, 5, 6, 7. Again, we have 8 data points. So 1, 2, 3, 4 would be half of that. There's half of that. And then half of that half is here. Half of the top half is here. So the median is going to be the average of 7 and 9, which is 8. Oh, very interesting here. It looks like we have the same 5-number summary, almost. The first quartile will be the average of 3 and 5, which is 4. And the third quartile will be the average of 11 and 13, which is 12. Okay, construct the box plots for each data set, one above the other. So they want us to do both box plots on one number line. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We only have 19 points here. So I can't do this in ones because my maximum value for the first data set is actually 23, and that would be off the number chart. So something you can do is decide what your scale is going to be so that you can fit both sets of data. I'm going to do it by twos. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I know that's a little mushed together, but you get the idea. Okay, so the first data set, the minimum is 1. So the 1 value is going to be here between 0 and 2. The maximum is 23, so we're going to come all the way over here, and it's between 22 and 23. The median is 8, so here is the median. First quartile is 4, so here is the first quartile, and then Q3, the third quartile, is at 12. Okay, connect the first 2 dots, connect the last 2 dots, make a box in the middle. And don't forget to draw the line for the median. There's your box and whisker plot or your box plot. Let's do data set 2. Here's what I want you to do. I want you to pause the video, and I want you to attempt to do your box and whisker plot or your box plot for data set 2 above the one we just drew for data set 1. And when you come back, we'll go ahead and we'll do it together so you can see how it's done, okay? But I want you to give it a try. So go ahead and pause the video and take a stab at it. Okay, so we're back. let's go ahead and look at data set 2. Our minimum value is 1 again, so I'm just going to come a little higher than the first one and put my minimum for data set 1. My max is 15, so 15 is going to be here. And I have the same median and quartile values, so I can just kind of trace these up here. Here we go. Connect the first two, connect the last two, make a box with these, and draw a line through the median. Okay, so I think the next questions actually ask us about this problem still, so I'm actually just going to slide this over. Yeah, here we go. Okay, so the first thing it says to do is to compare and contrast both box plots. So I'm going to use a different color to answer these, and what I want you to do at this point is pause the video and answer these questions on your own, and then we will go through them together. You're going to be telling me what is the same about these two box plots and what is different about these two box plots. So pause the video, answer those questions right there, and then we'll come back. Okay, so if we're talking about what's the same here, I think it's pretty easy to tell that the min, quartile 1, median, quartile 3 values are the same for these two data sets. The only thing that's really different is the maximum value. The max value on data set 1 is much further out than the max value for data set 2. So what's the same is the min, the Q1, the median, the Q3, and what's different is the max. Okay, explain which box plot is not symmetrical and justify your answer. Okay, so if we're looking at the box plots, you could look at the first shape here, okay, and you can measure the distance between the points and decide what's happening with those. This is 1 to 4, that's a value of 3. And then this is 4 to 8, which is a value of 4. And then this is 8 to 12, another value of 4. And then from 12 to 16, is that what that is? Let's see. No, the maximum is 15. So this is actually 12 to 15, which is 3. If you cut this figure in half, you get 7 on this side and 7 on this side. And if you folded that on top of each other, those two halves would be perfectly symmetrical. So box plot for data 2 is symmetrical. And then let's look at the other one. I think you can easily tell that the box plot is not going to be symmetrical because the maximum for this one is so far out that if you counted or measured this data point here, this would be much larger than the 3 that goes from 1 to 4. So this one is not symmetrical for that reason. Okay, it says explain which is not symmetrical. I'm not going to write anything there. I'm just going to say see diagram because I kind of did my answer already in green over there. If you want, you can write out something there in the notes so that you can kind of remember how we came to that conclusion. Okay. All right, so that's gone. In these notes, there's only 2 more problems. We'll go through them together. For question number 1 under the let's practice, it says consider the following data set with an odd number of data values. So remember, if there's an odd number of data values, we have to do something a little different in terms of finding what's the median, Q1, Q3, etc. So I'm going to use, let's do orange. I haven't done orange yet. So 1, 2, 3 points, middle, 1, 2, 3 points, okay? So that means that 3 to 10 is the bottom half and 15 through 21 is the top half. This is the median. The min is 3 and the max is 21. That's still the same. How you find Q1 and Q3, the quartiles, is you look at the bottom half and find the median, and you also look at the top half and you find the median. So if we're looking at 3, 7, and 10, the median value that you see right there is 7. So this right here, which is right in the middle of 3 and 10, is going to be Q1. The same thing for the upper half. You're just going to look. There's 3 data points here in this set. So the middle point is going to be 18. So that would give us Q3. Okay, so let's answer these questions. The min is 3. The max is 21. The median of the entire data set, the median is 11. The first quartile we just said was 7, and the Q3 is 18. Now it says construct a box plot that represents this 5-number summary. That's pretty easy to do. We just did a couple of those. Our minimum is 3 and our max is 21. I'm probably going to go ahead and do this by 2s just so I can save some time. So if this is, let's start at 3. We'll just start at 3, and then we'll go 3, 5, 7, 9, 11, 13, 15. What's the max? 21. 17, 19, and 21. So this point right here is 21. The min is 3. The max is 21. The median is 11. So we have a median here at 11. We have our first quartile at 7. And our third quartile at 18. So 18 is between 17 and 19. We have all 5 of those numbers plotted. They're going to connect the first 2 and the last 2, and then you're going to make a box with the middle 3. Done. And then don't forget to draw the line through the median. Okay. So there is your box plot. It's finished. Let's go ahead and wrap these notes up with our last problem here, which is the try it. It is the time rounded to the nearest hour that 26 tourists spent on excursions in Cat Island, Mississippi on a given day. And here's the data set. So they told you there's 26 data points already. And this is measuring how much time each of those 26 people spent on an excursion in Cat Island, which is apparently not actually an island for cats. I'm shocked. Aren't you shocked? Okay, so with our 26 data points here, we know that 26 is an even number, and so that means we need to find the middle and cut it in half. So half of 26 is 13. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the halfway point. Okay, so in the bottom half of our data set, we have 13 points. So the median of the bottom half is going to be the middle value of 13. So if we count to 6, 1, 2, 3, 4, 5, 6 data points, the 7th data point is going to be the median, and then you're going to have 6 more above that. So this 6 right here is the median. This right here is Q1. And then if we do the same thing for the top half of the data, we have 1, 2, 3, 4, 5, 6. The 7th value right here is going to be Q3. And then you have 6 more, 1, 2, 3, 4, 5, 6 data points to the right of that. So our minimum is going to be 0. And our maximum is going to be 12. And let's just go ahead and do the median right here for the whole data set, which is 7.5. And that is the median. So we basically found all of the numbers in the 5-number summary. We're going to use that information to construct a box plot, and then we're going to label all of those pieces of the 5-number summary. So this goes from 0. Our data ranges from 0 all the way up to 12. There's plenty of data points here that we could put, plenty of notches on this number line that we can plot this. So I'm just going to go in increments of 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's plot these. So the minimum is at 0. The Q1 is 6. And then the median is 7.5. And then Q3 is 9. And then we go up to 12 for the max there. Okay, so you're going to connect the first 2, connect the last 2, and then use these 3 in the middle to make a box. And don't forget to mark the median. So this is min and max. This is Q1. This is the median, and this is Q3, so it's labeled. Okay, it says the bottom 25% of tourists spent at the most blank amount of hours on excursions. So the bottom 25% is going to be the entire first quarter or quartile of the data. That's going to take us from 0 up to the median of that, which is going to be 5, okay, because we don't include the value that is the median in this example. So 0 through 5. So the most they spent in that category, the lowest 25 is 5 hours. Okay, so that's it for the notes. And then what I'm going to show you next is actually how to complete the assignment that's in Delta Math. So we're going to pull that up. And here's what your problems are going to look like. They're going to give you a set of data, and then they're going to ask you to find the 5-number summary and then create the box plot. So let's do the 5-number summary first, then we'll move on to the box plot. This is our data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. That's an even set. So in the even set, we're going to go ahead and we're going to go to the middle to cut it in half. So I think I said 12, so we're going to go up to 6. 1, 2, 3, 4, 5, 6. So this is the median right here. The average of 6 and 9 is going to give us the median. The lower half is between 4 and 6, and then the upper half is between 9 and 16. Because there's 6 values on each side. So the minimum is going to be 4. The median is the average between 6 and 9. So if you add those together, you get 7.5. The maximum is 16. The Q1, so here's the lower half, right? It's these 3 pieces of data. So Q1 is going to be the middle of 6 and 6. Well, if you add 6 and 6 together, that's 12, and if you divide it by 2, it's 6 again. So the Q1 is going to be 6. And then I'm going to go from 9 to 16. This is the upper half of the data. You're going to find the middle point and average the 2 values that are near it, which is 10 and 10. So since they're the same, the Q3 is going to be 10. Okay, so basically on the box plot down here, or the box and whisker plot, you're going to go ahead and see how when you get to a certain piece of the graph, my cursor changes to a hand, which means I can click on it. So you're just going to drag these around to the appropriate point. So this is the min. We're going to drag this over until we're at 4. The Q1 is at 6. Okay, it's already at 6, so that's good. The median is 7.5, so this needs to come back over here to 7.5. The Q3 needs to get moved to 10, which is here, and then the max is 16, so we're going to pull this over to 16, and we're good to go. So let's go ahead and submit our question here, and it looks like we got a green check mark, so we're right. And you're going to have 5 of those to work on, and so you can go ahead and just log into Delta Math after you're done with these notes and check those out. I hope that was a good lesson for you on box plots, and I'll see you in the next video, which will be on Wednesday for class time. If you have any questions about anything that we've covered in this video or any of the other topics we've done so far, feel free to send me a message on Remind or send me an email. You can comment on Google Classroom, and then we can have a Google Meet and kind of go over and fill in the missing information, okay? All right, guys, be well, be safe, and see you in the next video. Bye-bye.